Hello, my name is Adam Roberts, and I'm an instructor here at Athens Technical College. As always, you can reach me at aroberts@athenstech.edu or call me in the office at 706-357-0162. Today, we're going to take a look at fire protection and detection and suppression systems, 5th edition, text by ISTA, Chapter 1, Overview of Fire Protection, Detection, and Suppression Systems. Our first objective is to describe the types of fire protection systems. Now, with that being said, let's do a little introduction here. Now, fire prevention has long been recognized as a responsibility of the fire and emergency services. In its truest form, fire prevention is the elimination of all hostile fires through the following: education, engineering, and enforcement. Of course, it can also involve mitigation, which is basically minimizing property loss or injuries. And this can be accomplished through such things as regulating the different types of products being stored there, the design of a building, and that goes from the products used to build it to, of course, the suppression systems or the redesign of a building. And this is very important in this day and age because we can all look at the strip malls or shopping centers, and one day you may have a Chinese restaurant in there, and the next day you may, have a daycare. And the question now, not only are we looking at, inspection and, of course, how things are being built and constructed, but we also need to focus on human nature. And this is an excellent example of our fire prevention programs, like learn not to burn, stop, drop, and roll, don't smoke in bed, things of that nature. Because if we can change this risky behavior through our target high-risk audiences, we can also minimize or wipe out these deadly fires that can occur. Now, fire protection, detection, and suppression systems can be a part of the course built-in environment, acting automatically upon discovery of a fire. They can also be used manually, as with such things as your fire extinguishers, your manual alarm systems, like your pull stations. And this chapter serves, of course, as an introduction to fire detection and protection systems. Including in this chapter, we're going to look at some of the types, history, and benefits of said systems. And now in additional chapters, we're going to explore and look at important codes and standards that impact the installation and users of fire protection and suppression systems. So let's go ahead and dive in and get started, gang. Now, the first thing we're going to look at are the types of fire protection systems. And there's two types here we're going to focus on. First being passive and the second being active. So when we're looking at passive fire protection, they can be a part of the building construction. And this includes such things as your firewalls, fire doors, sprayed-on insulations, and things of that nature. Now, it's important to note that these systems are passive in that they perform their function. This is key here. They perform their function with no outside intervention or mechanical support. Now, one drawback of these systems is they cannot warn occupants of danger of unwanted fire, and they do not, do not suppress the growth of the fire. Now, as we may or may not know, when we're looking at what significantly prevents large loss of life due to fire, that totally goes back to, of course, early detection and the signaling of an appropriate alarm to alert occupants of a fire. So it's not really a passive fire protection system, but an active one that accomplishes this. So active fire protection systems are fire protection, detection, and suppression systems that activate and operate automatically or manually and alert occupants upon the presence of such things as smoke and fire. These systems, when activated, are designed to change the course and outcome of a fire in a building. These systems work to the benefit of the building owner, its occupants, and the responding fire department personnel. Now, active systems are the main focus of this text. Our active fire protection systems can be divided into two very broad categories, and that is your fire detection and fire suppression systems. Now, again, remember our fire detection systems alert occupants to the hazardous conditions or changing fire conditions by automatic and or the manual fire alarm equipment. The early detection of a fire and the signaling of appropriate alarm remains the most significant factor in preventing large losses due to fire. Okay, let me repeat that. The early detection of a fire and the signaling of an appropriate alarm remains the most significant factor in preventing large losses of life due to fire. Now, your fire suppression systems are those that control and contain hazardous conditions until manual suppression can be achieved. Now, many of these systems are your water-based systems, and of course they work together with your fire detection and suppression systems, and of course they save lives and decrease your property loss, and also help with early mitigation and control of fire. A good example of this would be, of course, our tried and true sprinklers. Sprinkler systems are a great example of our active fire suppression systems. And when we combine our fire detection systems with our suppression systems, that equals saving lives and decreasing property loss by notification, early mitigation, and control of the fire. So, some food for thought, review question. What is the difference between fire detection and fire suppression systems? Learning objective number 2. Summarize the historical development of fire protection, detection, and suppression systems. Now, when looking at fire protection, the concept of detection and suppression system is deeply rooted in the history. And the first fire alarm system was installed around 1851. Now, this was a municipality alarm system that used a telegraph to notify the fire departments of a fire. The first commercially successful automatic fire sprinkler system was patented in 1872, And in 1902, George Andrew Darby, an electrical engineer, patterned the first heat indicator, which sounded a fire alarm when activated. This early device paved the way for today's battery-powered smoke alarms, which Kenneth House and Randolph Smith introduced in 1969. Now, many catastrophic fires throughout history have served to increase the promotion and use of fire detection and suppression systems. Many of these events prompted changes in codes and regulations concerning the design, strict requirements on assembly occupancies. Now, these devastating events and suppression systems and provide much evidence as to life-saving benefits of these systems. So basically, in a nutshell, what they're saying here is that because something extremely catastrophic happened, we did something about it. And I hate to say that when we're looking at fire protection systems and the fire service as a whole, we are not very proactive like we should be. Unfortunately, government and industry is mainly reactive, meaning that something happens and we finally decide to do something about it. And if we really look throughout history, a lot of our codes, and we'll talk more about this later, and protection systems and designs and things of that nature were not brought about by legislation initially. It was brought about by the insurance companies forcing the hands of these business owners to do something to make the buildings safer and more fire resistant to prevent, unfortunately, loss of life and, of course, loss of money in the terms of building and equipment that was insured by these agencies. So let's look at some of our notable fires. And you can Google all these fires, and for my fire science students, there'll be links in Blackboard for this week, and I want you to watch a few of these videos because I'm not going to go too in depth on these at all. There's a lot of information in the text, feel free to read, but the videos do a good job, and of course I don't want to play the videos here because that'll take forever. But if you look at them, all your fires here, from the Triangle Shirtwaist Factory in New York City in 1911, you had 145 loss of life. The Coconut Grove nightclub, 492. The Winecoff Hotel in Atlanta, 119. The Stanton nightclub fire, and this is more modern times, that was in 2003, and you had 100 individuals that lost their life. And again, I'm going to put links to these up on the website, but if not, feel free to Google them, gang. If you're watching this on YouTube, watch these videos. And I tell you, the stories are just heartbreaking on the tremendous loss of life and what led up to these terrible events happening. And of course, as the result of these events in the videos and the text, it will tell you the applicable changes that were brought about because of them. Okay, so let's hit the highlights of these fires. Iroquois Theater Fire of 1903. Scenery was made of canvas painted in highly flammable oil paints. There were no automatic sprinklers. The stage fire curtains did not close properly. There was no emergency lighting, and the smoke and heat vents were not functional. Also, many of the exit doors were locked and did not open in the outward direction. The Triangle Shirtwaist Factory of 1911. And if you guys have Netflix or HBO on demand, they did a great documentary on this one. The company was located on the 8th and 10th floors in a high-rise building. There was a cigarette that was tossed in a scrap bin of cloth. The 8th and 10th floors evacuated, and 250 employees on the 9th floor were not informed of the fire until the 8th floor was well involved, cutting off their escape. Now, this occurred at closing time, and there was only one of the two exit doors that were locked on the 9th floor. So that limited the egress, and the reason they did that was to better control the flow of the people leaving so they could check and see if they were trying to take home scraps or cloth products of that nature. The unlocked exits and doors were inaccessible at the time, and the doors not locked were blocked by machinery, supplies, and equipment. And the fire escape also failed during its use. Coconut Grove nightclub fire in 1942. Modern Marvels History Disaster has a great one on this. And one account is that the fire was started by a busboy with a match while changing a light bulb in an artificial palm tree. However, recent studies and things of that nature says this probably wasn't the case, that it was actually due to air conditioning unit that was leaking a flammable gas. Unfortunately, the busboy did ended up committing suicide over it because of his tremendous guilt and, of course, the death threats from the family. But officially, the cause was determined to be unknown of origin. The nightclub was filled to twice its capacity. There were no automatic sprinklers. And again, the exit doors swung in the wrong direction. And of course, doors and windows were sealed shut to prevent people from exiting the establishment, of course, without paying their bill. And the main exit was a revolving door that prevented folks from getting out in a speedy manner. The Weinkauf Hotel of 1946, the deadliest hotel fire in U.S. history to date. One exit stairway, which became impassable early. The doors were propped open. We're talking about fire doors here, so that allowed the fire to spread. No fire suppression or alarm systems were present, and there was no way to notify the hotel occupants that were asleep at the time, because this occurred in the early morning hours, that, hey, building's on fire, you may want to get out. K.E. Jane Memorial Home, 1957. This is one of the deadliest nursing home fires in U.S. history, and we all can think about a nursing home and the mobility of these patients and bed confined patients, and what a disaster that would be if a nursing home did catch fire in your jurisdiction. It is believed to have started due to faulty wiring in the ceiling and walls, and I'm not surprised. Having to go up in an attic and check where a fire alarm was going off in the past, and seeing the holes that were put in your firewalls to run such things as cable line, air conditioning ductworks, and things of that nature, and just the poor housekeeping at this particular establishment I went through, I can believe it. But other issues with this particular structure was no sprinkler or alarm systems. The only means of escape was an unclosed interior stairway that emptied into the main building, and there was no outside fire stairs or slides for a quick egress. Our Lady of Angels School, 1958. Deadliest school fire in U.S. history, and now this one started in the basement, trash can in a stairwell. The structure's wooden staircase was quickly engulfed in flames, and location of the fire blocked, of course, our escape routes for the occupants that were trapped on the second floor. Exit corridors had combustible walls and ceilings present. Again, no sprinkler or alarm systems on premise, the stairwell was not enclosed, and a delay in notification of the fire department also occurred. Beverly Hills Supper Club, 1977. Getting a little more modern here, right? Memorial Day weekend, and the building was packed with over 3,000 patrons. There were inadequate egresses and exit identifications. People didn't know where to go, and there wasn't enough of the exits. Again, no fire suppression or fire alarm systems. Again, kind of hard to believe because we're talking about 1977. We're thinking this is, more of a modern age, right? The fire began in an unoccupied room, and it is believed to be electrical in nature. The fire did burn for some time before it was discovered, and at that point, it quickly spread to other parts of the building. The employees did fought the fire prior to notifying the fire department or occupants. So they were trying to handle it themselves without, starting to be proactive and getting the appropriate people there to mitigate the fire and, of course, get folks out. They tried to handle it themselves, and, of course, they were unable to. MGM Grand Hotel, 1980. The hotel did have a sprinkler system. However, the casino did not. The hotel had many unprotected vertical shafts with openings that allowed the smoke to enter and fill the exit stairwells. Occupants entering the stairwells were unable to return to their rooms or floors due to an automatic locking door. So essentially, they got trapped in this smoke-filled environment and could not get out without going through it. The Station nightclub fire of 2003. Again, there's some just incredible videos of this online. Do a Google search, look at YouTube. But it is due to the fact that there were pyrotechnics that were used during a band performance, and this ignited the soundproofing foam at the back of the stage. Of course, it was also highly flammable. Gee, there's some a good idea. Let's have a highly flammable soundproofing material, and let's put pyrotechnics right to it. There were no automatic sprinklers. The individuals panicked and failed to use the secondary exit routes. People rushed for the front door, which became jammed with bodies and people, and most of the victims died trying to exit at the front of the club. So people were getting trampled, black smoke was pouring out, you had fire everywhere, and it was just an unfortunate massive mob. And, this kind of goes back to human nature, that when you enter a building to eat dinner or anything, do we really take note of our alternate means of egress, other places to get out? And most people do not. And I think that is something, personally, that our fire safety education folks should, kind of put out there as a focus when we're trying to change people's habit. Now, in public safety, law enforcement, fire, EMS, with our situational awareness, I think a lot of us, when we go into a place, we're kind of looking to see, okay, if things go south, what's another way to get out than the way I came in? Where the average person, that's all they realize or think about is, hey, I came in this main door, I'm going out this main door. But when you got a crowded place, guess what? Everybody else is thinking the same thing. They're not thinking, oh, hey, there's a window over here on the B side of the structure, or hey, right by the stage, there's a back exit door, or things of that nature. Okay, so the necessities of fire protection and detection and suppression systems is obvious from all these historic events. Unfortunately, the large loss of life and the need for early notification of occupants in the fire department resulted in codes and regulations being adopted, modified, or more strictly enforced because of these fires. Again, an excellent example of how we were reactive as to proactive in terms of taking care of the situation. Okay, gang. Moving on to our next section, and feel free to go ahead and hit the 5-hour energy drink or your Mountain Dew, because this can get a little dry. Some of this stuff does. So, in addition to these historical benchmarks, 2 early reports have influenced the requirements for fire protection, detection, and suppression systems. Now, these reports were prepared by groups that came together to address the unacceptable fire problem in America. And both reports prompted the use of fire protection devices for life safety and loss prevention. And the two are the Fire Prevention Conference Report, and the second is National Commission on Fire Prevention and Control Report, one in 1947 under Truman, and the second in 1970 under Nixon. Now, President Harry Truman called for and participated in the 1947 Fire Prevention Conference. Now, this group was brought together to review the fire problem in the United States and to identify deficiencies in the American fire service. Now, the purpose of this group was to determine ways to increase both the level of awareness about the fire problem and the, quote, work of fire safety in every community. Now, regarding fire protection, detection, and suppression systems, the conference stated that all municipal fire prevention ordinances should be combined into one fire prevention code. The report also recommended better building designs, the use of technology for prevention, and an increased focus on prevention education. Specifically, the report recommended the widespread use of fire extinguisher equipment, hoses, standpipes, automatic sprinkler systems, and alarm systems in buildings. Education, engineering, and enforcement, also referred to as the 3 E's of prevention, came as a result of this conference. Again, let me recap that. So the 3 E's of prevention are education, engineering, and enforcement came as a result of this conference report. Individuals involved in fire protection practices realize that all 3 components must be implemented in order to reduce the number of fire deaths and related injuries. As a result, fire prevention programs achieve more successful outcomes. Okay, now the second report came as a result of President Richard Nixon convened the National Commission on Fire Prevention and Control in the 1970s. Now, the commission produced a very famous report entitled America Burning, which has had a significant impact on the fire service, fire prevention, and fire protection in the United States. Overall, recommendations included the improvement of fire protection features of buildings. Specifically, this report identified the need for automatic fire extinguishing systems in every high-rise building and every low-rise buildings where people congregate. The report also recommended that economic incentives be provided for built-in fire protection. Now, this report resulted in the passage of Federal Fire Prevention and Control Act of 1974. The impact of this publication has been enormous in the areas of fire protection, and fire service training, as well as public education. Since that time, the requirements for fire suppression and detection systems in commercial and multifamily residential structures have been incorporated and expanded. Additionally, many states and local jurisdictions have codes and regulations addressing requirements for such systems in 1 and 2 family dwellings. Review question. What are some events that have become benchmarks in the history of fire detection and suppression systems? And remember, that could be the legislation, the reports that we just talked about, or even the fires. Learning objective number 3. Describe the 4 basic categories of fire protection, detection, and suppression systems. Okay, time for another hit of the old espresso, coffee, or a 5-hour energy drink, because again, boring stuff. Now, a variety of fire protection, detection, and suppression systems exist, and these systems can be divided into 4 basic categories. First being automatic fire protection, detection, and alarm systems. Now, they are activated by smoke, high temperatures, radiant heat, or flame signatures. And they alert the occupant in the building and or the fire department to the fire. These systems do not slow the growth of the fire or reduce the amount of smoke that is produced. Again, this one is just a warning device. Next, we have automatic fire suppression systems, and they work to suppress the fire hazard by applying a fire suppressing medium to the fire, whether it be water or CO2 or whatever the case may be. Now, human intervention is not needed for their effectiveness. This process reduces the hazard to the occupant, to the building and its content, and to the responding firefighters as well. Manual fire alarm systems require activation by an individual upon the discovery of a fire. Devices such as manual pull stations are common components of the manual system, and you can see those pretty much everywhere in any building you go to, whether it be schools, stores, or wherever the case may be. Next, we have manual fire suppression systems. Now, this includes standpipes, both your vertical and horizontal ones, fire hoses, and fire extinguishers. These mechanisms require an individual to operate them in order to perform their function. They are not automatic. Okay, go ahead and regurgitate the 4 basic categories of fire protection, detection, and suppression systems. Duh. Okay, moving on. Objective 4. Explain the role of standards and codes for fire detection and suppression systems. Now, as previously indicated, standards and codes have traditionally been developed and adopted in response to historic tragic events. Standards and codes are used to establish minimum requirements for the design and construction of building, structures, and facilities. They are also used to determine the type and extent of detection and suppression systems needed. Standards and codes establish the minimal level of safety that should be present in a structure. Now, the AHJ must adopt this minimum with code official enforce. Organizations that specialize in the development of standards and codes often create them. And in order to be enforced by law, the authority having jurisdiction must adopt standards and codes. Again, as a reminder, the definition of code is a collection of rules and regulations enacted by a legislative body to become law in a particular jurisdiction. Building and fire codes may be adopted in two ways. The first way is by transcription, where the entire code is copied into a regulation. The other method is by reference, where the regulation states that the reference code is legally enforceable as part of the fire and life safety regulations. Now, codes can be adopted in whole or in part and may be amended by the jurisdiction through the adoption process if allowed by the governing authorities. Standards attempt to obtain consistency in design, practice, and materials, and can provide a guide of practices and designs that have proven to be successful. Many standards and consensus standards, meaning that a group of experts have developed and agreed upon the standard before it is adopted. Before codes were developed, a wide variety of interpretation and even confusion for requirements existed. Model codes were developed to provide agreed upon requirements for areas such as fire and life safety or electrical equipment. These codes are similar to consensus standards in that a group of agreed upon the code before it is adopted into model. A variety of organizations publish consensus standards and model codes. The National Fire Protection Agency, known as NFPA, is the most familiar organization. The NFPA publishes the majority of the consensus standards used in the United States and Canada. Since the 1880s, the NFPA has published a variety of standards and other documents dealing with fire prevention and building safety. Many of these standards address the various fire detection and suppression systems that are required for specific occupancies or buildings. Next, we have the International Code Council, known as ICC. This is a membership association dedicated to building safety and fire prevention. It was established in 1994 as a nonprofit organization that is dedicated to developing a single set of comprehensive national model construction codes. The ICC developed the codes used to construct residential and commercial buildings. The Council's founders included the Building Officials and Code Administrator International, known as the BOCA, International Conference of Building Officials, and the Southern Building Code Congress International. These three organizations have previously developed separate set of model codes that were used throughout the United States. The Canadian Commission of Building and Fire Codes develops and maintains Canada's model codes. Now, Canada has 6 model construction and fire codes, including the National Fire Code of Canada and the National Building Code of Canada. These comprehensive building and fire life safety regulations are used throughout Canada and address construction and fire protection system requirements for building and occupancy classifications. Next, we have ASTM internationally, originally known as the American Society for Testing and Material. It is one of the largest standard developing organizations and is considered to be a trusted source for technical standards for material, products, systems, and services. ASTM International develops testing processes that other testing organizations use in the development of safety products. Similar to ASTM, we have UL, or Underwriters Laboratory Incorporated. And this is a great resource, and if you haven't already, check out their website because there's a lot of good information on there. Now, UL is an independent, non-for-profit product certification organization that has been testing products and writing standards for safety since 1894. UL annually evaluates thousands of products, components, and materials and systems. UL has developed over 800 standards for safety. Some of these standards relate directly to fire and life safety, such as smoke detectors for fire alarms and dry chemical extinguishers. Next, we have FM Global, formerly Factory Mutual. This is a proprietary insurance company that works to provide proprietary improvements for business ownerships to prevent risk. The organization works in partnership with businesses and industry to reduce property damage through the state-of-the-art property loss prevention research and engineering and comprehensive insurance products. FM Global provides product certification and testing services throughout an approval process and specific testing. Next, we have the U.S. Occupational Safety and Health Administration, or better known as OSHA, which recognizes nationally recognized testing laboratories as having the capability to provide product safety testing and certification services to the manufacturers of a wide range of products. The testing and certification are based on widely accepted product safety standards and are often issued by the American National Standard Institute. These testing agencies must meet the certification requirements of OSHA's Director of Technical Support and Emergency Management. Both UL and FM Global are certified as NRTLs and through OSHA. Other smaller testing laboratories include Southwest Research Institute, Wiley Laboratories, and the Canadian Standard Association. OSHA provides a complete list of these agencies on its website. ANSI coordinates the development and use of voluntary consensus standards in the United States. ANSI is also involved in the accreditation programs that assess conformance to standards in business, including the International Organization for Standards, ISO 9000 and ISO 1400 management systems. ANSI standards may be cross-referenced between NFPA and OSHA documents. Now, jurisdictions base their building and fire codes from this wide array of sources. These codes are designed or designate the degree or level of protection required in a building based upon its occupancy, construction type, and other designated variables. Review question. What are two ways that building and fire codes can be adopted? Objective 5. Describe the benefits that fire protection, detection, and suppression systems have on life safety and loss prevention. The influence of fire protection, detection, and suppression systems on life safety cannot be overstated. The positive effects for both building occupants and firefighters are readily apparent by an examination of historical data. In each of the fires discussed previously, the investigations reveal the lack of fire alarm systems and fire suppression systems as a major contributing factor in the deadly results. According to estimates by the NFPA and the United States Fire Administration, the U.S. home usage of smoke alarms rose from less than 10% in 1975 to 94% in 2000. This data was drawn from USFA Topical Fire Research Volume 1, Issue 15, Smoke Alarm Performance in Residential Structure Fires. Now, at the same time, the number of home fire deaths was cut nearly in half. The relationship between improved use of smoke alarms and lower death rates due to fire is not a coincidence. Because of this drastic reduction in fire deaths, the home smoke alarm is widely credited as one of the greatest success in fire safety in the last part of the 20th century. The NFPA states that a properly installed and maintained automatic sprinkler systems will reduce the average property loss from fire by 1/2 to 2/3. According to the USFA, property loss are 85% less in buildings that are protected with fire sprinklers compared to those buildings without sprinklers. The combination of automatic sprinklers and early warning systems in all building and residence could reduce injury, loss of life, and property damage by at least 50%. The U.S. Fire Administration has proposed research, development, and testing and demonstration of residential fire sprinkler systems for more than 30 years. The USFA research regarding residential fire sprinkler systems shows that these systems can do the following: save the lives of building occupants, save the lives of firefighters called to respond to a home fire, and significantly offset the risk of premature building collapse posed to firefighters by these lightweight construction components when they are involved, as well as substantially reduce property loss caused by fire. The Fire and Life Safety section of the International Association of Fire Chiefs has stated priorities for the promotion of fire and life safety. These priorities include reducing death from structure fires to zero and limiting property damage from structures to the area of origin, as well as reducing firefighters' fireground deaths to zero as well. In pursuit of these priorities, the IAFC advocates complete automatic fire sprinkler protection in all new occupied construction, including 1- and 2-family dwellings. The association also advocates fire sprinkler retrofits of existing high-rises, institutional, and other high-risk, high-consequence occupancies. In addition, the IAFC recommends educating all firefighters on the benefits of fire sprinkler protection and reducing firefighter deaths. In addition to protecting civilians and their properties, there are also benefits to emergency responders. In its work to reduce the number of firefighter deaths and injuries, the National Fallen Firefighter Foundation, through its Everyone Goes Home program, Firefighter Life Safety Initiative, states that advocacy must be strengthened for the enforcement of codes and the installation of home fire sprinklers. This program lists 16 initiatives that can be incorporated into fire and emergency service organizations to help meet the program's objectives. Review question: how are automatic sprinkler systems beneficial to life safety and loss prevention? Okay, what we've all been waiting for, the summary slides. That means we're in the home stretch and almost done, gang. So to summarize this chapter, fire protection, detection, and suppression systems are of vital importance in the goal of fire prevention. Now, while these systems may be unable to prevent a fire from occurring, they work effectively and efficiently to prevent the loss of life and large property loss. History demonstrates that the seriousness of fire problems and the tragic toll it can take. Fire protection, detection, and suppression systems allow fire professionals to achieve their goals of life safety and property protection. Okay, gang, if you haven't already, go ahead and make sure you do the review questions for this chapter. And as well, please look at some of the videos in regards to the loss of life fires, or feel free to Google them if you're not in Athens Technical College Fire Science program, though I wish you were. And remember that this is an associate's degree program where individuals can receive their associates in fire science technology, and this is also an online program. So gang, if you have any questions, feel free to send me an email at aroberts@athenstech.edu, or you can reach me in the office at 706-357-0162. And until next time, be safe and have a great shift.